Composition of functions. In the past, we've looked at function notation, and so we've learned what it means to be a function, or what a function looks like, how to evaluate a function. But now the question is, what can I do with those functions? What are some of the different computations, compositions, different things I can do with functions? So that's the plan for this recording. First thing, I made a comment in the last recording that function notation will never mean multiplication. When a function name, an f, a g, an h, is placed next to a parentheses, it will never mean multiplication. If I want to mean multiplication, then I will put a multiplication symbol, or your book or other books will use multiplication symbol. That means multiply. That does not mean multiply. Okay? So this here does not mean multiply the function by 2. What it means is evaluate f of 2, evaluate g of 2, and add them together. F plus g at 2, f plus g of 2, simply means evaluate each function at the given x value of 2 and add them together. So to evaluate a function from the last recording, we put in 2 for the x in the f equation. So my 2 goes into there. And I put 2 into the g equation for x in both places. I evaluate it, meaning I work it out. 2 times 2 is 4, minus 4 gives me the 0. 2 squared plus 4, 2 squared is 4, plus 2 is 6, minus 3 is 3, 0 plus 3 is 3. When you do basic computation with functions, it is simply evaluating each function separately and either adding, subtracting, multiplying, or dividing. Your turn. Let's try a few. Can't read my writing. Whenever you feel comfortable and you're ready to go, hit pause and you can give them a try. I'm going to write 4 problems total. All right, question 1. Hopefully you had time. If not, hit pause and keep going. F of 1 plus h of 1. I like doing that next step. I like writing it out. Just to keep clear what it is we're trying to find. F plus h of 1 means find f of 1, find h of 1, and add them together. So plugging in 1 for x in the first equation, or in the f equation, I get that. Plugging in 1 in for h, I get 1 over negative 2, correct? Putting in a 1 here for x. So on this first part, I get negative 2 minus a half equals negative 2 and a half. F of 1 plus h of 1 is a negative 2 and a half. Let's try g. What does this tell me to do? This says find g of 2, find h of 2, and multiply them together. G times h of 2. Find g of 2, find h of 2, and multiply them together. G of 2. Plug in 2 for x, I get 2 squared plus 2 minus 3, which is 3, times h of 2. Plugging in 2, I get 2 minus 3, which is a negative 1. And a negative 1 times 3 is equal to a negative 3. G of 2 times H of 2 is equal to a negative 3. Number 3. What does this mean? This means f of 3 divided by h of 3. Putting in 3 for f. 3 times 2 is 6. 6 minus 4 is 2. Plugging in 3 for h, I get 1 over 3 minus 3. 1 divided by 0. What's 1 divided by 0? Not possible, right? 1 divided by 0 is not 0. 1 divided by 0 is not possible. Huh. That means we have some things that are not a part of my domain. Remember our talk on domain and range. What this says is I can't evaluate h at 3. The value of 3 will not be in the domain of h. We're going to talk about that a lot more in just a second. Okay, so what is the answer to this one here? Not possible. No solution. Either one of those is fine. Not possible because you cannot plug in a 3 for the h. All right, the next one. G times f of 1 is g of 1, negative 1, times f of negative 1. G of negative 1 tells me to put a negative 1 in for g, so I have a negative 1 squared plus a negative 1 minus 3. Multiply that times negative 1 times 2 minus 4. And I get 1 minus 1 minus 3 is 0 minus 3, which is a negative 3, times 2, negative 2, minus 4, which is a negative 6. Answer is 18. G of negative 1 times f of negative 1 is 18. Okay, that's the first part. Composition, or a basic computation, addition, subtraction, multiplication with functions. All right, let's do a new notation that you've not seen before. Maybe you have, called the composition of functions. All right, using the same functions, let's do this one. F composed with g, or f following g. What this means, I don't want an x, let's put a number in there. What this tells me to do is f of g of 1. Evaluate g of 1, take the answer to that and put it into f. Evaluate g of 1, take the answer from g of 1 and stick it into f. So, what do we get? G of 1 is equal to 1 squared plus 1 minus 3, which is equal to 1 plus 1 is 2, minus 3 is a negative 1. Putting in 1 for g, I get a negative 1. Now evaluate f of a negative 1. So it becomes 2 times a negative 1 minus 4, which equals a negative 6. The answer to this is a negative 6. Okay? F of g of 1 is how you'd read that. All right, your turn. Oops, that's fine. give those a try. How would I write this one here in the other notation, the composition function notation? It would look like that. So either one of those notations mean the exact same thing. We'll go back to the first one just because I think that's the easier one to see. This says find h of 2 and put the answer into f. So h of 2 means 1 over 2 minus 3. 1 over 2 minus 3, oh, this one came out to be negative 1 also. 2 minus 3 is a negative 1. 1 divided by negative 1 is a negative 1. F of negative 1, we already did before. This one also happens to be a negative 6. That is not normal. Okay, that was just a coincidence. So don't think it's always going to end up with a negative 1. All right, number 2. G of f of negative 2. F of negative 2 says to take negative 2 and plug it in. I get negative 8. G of negative 8 says to plug a negative 8 into that equation. Negative 8 squared is 64, positive. Minus 8 minus 3 is equal to 53. The answer to this is 53. Okay? All right. Let's start with some new functions. All right, let's just use these two functions. Now, what if I have f plus, no, I gotta do one more, sorry. I don't want to use fractions all the time. That would make things too confusing when it doesn't need to be for some of these. All right, so what if I have f plus g of x? And I don't have a number in there, but I have f plus g of x. And I want you to simplify or evaluate that function. What that means is to take f of x, just like we did if that was a number, plus g of x, and add them together. So I simply need to take f of x, which is x plus 3, plus g of x, which is 2x minus 1, and write it as an addition problem. Combine like terms. X plus 2x is 3x. 3 minus 1 is a positive 2. And so f plus g of x is equal to 3x plus 2. Okay. Remember earlier in the recording, when I plugged in that value for h and I got a no solution, which stated that there could be some problems with the domain. So when I do a composition of functions where I just have an x in there, I have to state, so what x values does this work for? When am I allowed to add f plus g of x together? What values of x will work? Well, if I think about 3x plus 2, is there any problem with plugging in any value for the x in this equation? Can I plug in a positive? Can I put in 3 times 100 plus 2? Sure. Can I put in a fraction? Sure. Can I put in a negative? Sure. Negative fraction, you get the idea. Answer for the domain is all real numbers. Okay? We don't care about the range, just the domain. We don't care what comes out of the function. We just care, is there something for x that doesn't work? Because we're saying, by writing this, we're saying f of x plus g of x is equal to 3x plus 2. Well, someone should ask the question, does it always work? Will it always be 3x plus 2? And the answer is yes. Every real number can be plugged in for x. Not always the case. What is f of? No, let's do it the other way around. let's do h of f of x. What does that function look like? That tells me to put f into h, correct? I'm going to put f, x plus 3, into h, right? This is f of x plugged into h of x. Typically, we had a number here, and we evaluated f of x, and we put that answer into whatever's outside, right? Like we did right back here. We found h of 2, took the answer to that, and we plugged it into f. Well, now I can't evaluate that. I don't know what f of x, the answer to f of x is, because I don't have an x value. I'm just going to plug in the entire equation of f of x and put it into the x and the h of x. Combine like terms on the bottom, and I get 1 over x minus 1. Does that one always work? Is the domain for this equation all real numbers also? Think about where the problem was last time. The problem is I can't divide by 0. Not possible. So the question you have to ask yourself is there a time when x will be equal to, when the bottom will equal to 0? Is there a value for x that will make the bottom 0? Yeah, 1. So x cannot equal 1. Let's write that in set notation. Think about how to do that. The set of all x, the set of all x such that x is not equal to 1. That is my domain. Cannot plug in 1 for x. Okay? All right. Let's try another couple. Domain is the hardest part. I'll put some up there. You give them a try. I just did that one, didn't I? I'll do a harder one. There you go. Okay, first one. Be careful with the negative sign. This is f of x minus g of x. F of x, x plus 3, minus g of x, 2x minus 1. That's a 1. Okay? This negative sign, let me rephrase that. The first term, the first expression. Do I need those parentheses in the first expression? No, not really. There's a 1 sitting out here. 1 times anything doesn't do anything to it. Do I need the second set of parentheses? Most definitely. This negative sign really has a 1 sitting right there. And I need to distribute that 1, that negative 1, to both terms. And when I distribute a negative 1, it definitely has an impact on your two terms. If that was a positive 1, I would not need the parentheses, because a positive 1 times anything is just itself. It doesn't change the value of it. But a negative 1 times a positive 2x is a negative 2x. And a negative 1 times a negative 1 is a positive 1. This is what the one, that's the sign that always gets people. Be careful on that. Okay. Combine like terms. X minus 2x is a negative x. 3 plus 1 is 4. So the answer to this is a negative x plus 4. All right, try number 2. Give myself some room again here. G plus h of x. Can't really do anything. We're done. But what's the domain? Oh, sorry, I didn't do the domain back here. I got to go back. What's the domain of that guy? I'll give you a hint. There's only two expressions that have a problem that we've talked about so far, that you know about, and that is a square root and a fraction. You can't square root a negative, and you can't divide by 0. If there's not a square root or a fraction, the domain's all real numbers. If there's not a square root or a fraction, your domain is all real numbers. Question 1, do we have a square root or a fraction? Nope. My domain, all real numbers. Question 2, do we have a square root or a fraction? Yep, sure do. Cannot divide by 0. What'll make the denominator, what makes the bottom 0? Domain, set of all x such that x is not equal to 4. Can't divide by 0. Okay. I think that is good for composition of functions. Hope that helps. Talk to you later.